Hi friends, welcome to Maths 369 YouTube channel. Today we are going to discuss about one of the important topic in second PUC, relations. First we'll discuss about the definition of relations. Let A and B are in two sets. A relation from set A to set B is a subset of A cross B. It is a subset of A cross B. The subset of A cross B that is defined as R is equals to A comma B such that A is related to B. A is related to B is subset of A cross B. Let A is equals to 1, 2, 3, 4, 5, 6 and B is equals to 2, 4, 6, 8, 10. R is relation from set A to set B. First example, A is related to B if A divides B. So when R is equals to 1, 2, 1, 4, 1, 6, 1, 8, 1, 10, 2, 2, 2, 4, 2, 6, 2, 8, 2, 10, 3, 6, 4, 4, 3, 3 also is there. So 3, 3 is not there, sorry. 4, 4, 4, 8, 5, 10, 6, 6. A is divisible by B. A divides B. First number is divides second number. So that this is the example for relation. Second example is A is related to B if A is equals to B. The A belongs to capital A and B belongs to capital B. Some the second set. A is taken from first set A and B. Second element B is taken second set B. So R is equals to 2, 2. So 2 is there, 2 is there. 4, 4, 4, 4, 6, 6. So number of order pairs will get 3 order pairs. So that is A is equals to B. So that is the relation. If A is related to B, if A is equals to B plus 2. So B plus 2, A value is twice, 2 times of B. So 2. A is equals to B plus 2. So 4, 2, 6, 4. These are the two order pairs we'll get. If you substitute B is equals to 4, B is equals to 2, then A is equals to 4. So B is equals to 4, we get A is equals to 6. These two elements belongs to given sets. Next example is if A is related to B, if A is equals to B plus 10. So in the set A, there is no value more than 10. So the elements of A are 1, 2, 3, 5, 7, 6. There is no element more than 6. So it is a empty relation, no relation. So now total number of relation from A to B is equals to total number of subsets from A to B. So if A has m elements, B has n elements, then the cardinality of A cross B, mn. So therefore total number of subsets is 2 power mn. So that equals to total number of relations from A to B. So that is 2 power m into n. Now total number of relations from A to A. A has m elements. For example, if A has n elements, then what is the total number of relations from A to A? The cardinality of A is n. So therefore total number of relations is 2 power n into n. It becomes 2 power n square. A is equals to, next another example, if A is equals to 1, 2, 3 and B is equals to 2, 4, 5, then find the cardinality of A cross B, that is the cardinality of A into number of elements in A into number of elements in B, that equals to 9. The total number of relations from A to B. So 2 power 9. Total number of relations from A to A also 2 power 3 square, that is 2 power 9. So number of relations from A to B that contains 1 comma 2, 1 comma 5 is, so we can write as 4 because the elements of A is 1, elements of A is 1 and B is 2 comma 5. So cardinality of A is 1 and the cardinality of B is 2. So 2 power cardinality of A cross A into B or AB, that equals to 2 power 1 into 2, that equals to 2 power 4. So this is the number of relations that contains 1 comma 2 and 1 comma 5 order pairs. The number of relations from containing exactly 5 order pairs, that is 9C5, because the cardinality of A into B is 9. Now discuss the types of relations. It's one of very important topic, very important concept. Types of relations: reflexive relation, symmetric relation, transitive relation, equivalence relation. So from these three you will get one 3 marks question for board exam. 3 marks question for board exam and one main JEE mains question. JEE mains. One JEE mains question you will get from this. One JEE mains question is important from this concept. So now we'll discuss that reflexive relation. A relation capital R on a non-empty set A is said to be reflexive relation if A belongs to A is related to A is related to A only. A is related to A belongs to A and A is related to A. That is A comma A belongs to R for every A belongs to A. It means every element of A is related to itself. Every element of A is related to itself and maybe that is related to and may be related to another elements also. So for example, if we see the example of reflexive relation, let A is equals to 1 comma 2 comma 3 comma 4 and R is defined by R is equals to 1 comma 1, 1 comma 2, 2 comma 1, 3 comma 3, 3 comma 2, 2 comma 2, 4 comma 2. So it is a reflexive relation because all identical order pairs are there. All identical order pairs. Identical order pairs are 1 1, 2 1 1. So this is identical order pair. 1 1, 2 2, 3 3, 4 4. These are the identical order pairs. When it is a reflexive, it means A comma A belongs to R. The identical elements are there in the given set. All elements, that is 1 1, 2 2, 3 4, 3 3, 4 4 is there, means that is reflexive relation. Otherwise it is not reflexive relation. Even one order pair is also missing, means that is not a reflexive relation. It means it contains 1 1, 2 2, 3 3, 4 4. It must. Then only it is a reflexive. Otherwise it is not reflexive relation. Let A is equals to 1 comma 2 comma 3 comma 4 and S is equals to, S is the relation 1 1, 1 2, 2 1, 3 3, 4 4. It is not a reflexive relation since 2 2 does not belongs to S. The order pair 2 2 does not belongs to S. So that is why it is not a reflexive relation. So every identity relation is a reflexive relation. Conversely, need not to be true. Every identity relation is a reflexive relation. Conversely, need not to be true. For examples, E is less than or equals to B, congruent, similar, parallel, XY living in the same place. These are the examples of reflexive relations. Now counting that. So number of reflexive relations. Let the cardinality of A is equals to N. A is equals to A1, A2 and so on AN. Write the Cartesian product of A cross A. A11, A12, A1N, A21, A22, A2N. So the number of diagonal elements is equals to N and the number of non-diagonal elements is N square minus N by 2. So therefore the total number of reflexive relations from A to A is number of choice remaining n square minus n elements, that is 2 power n square minus n elements. So this is the reflexive relations formula. Non-reflexive relation. A relation R on set A is said to be non-reflexive relation. That is, A comma A does not belongs to R. Reflexive relation means it contains A comma A. A comma A does not belongs to R, at least one of the order pair. So here, for example, if you take A is equals to 1, 2, then we can write as R1. Non-reflexive is 1 comma 1, 1 comma 2. This is a non-reflexive relation. Here 2 comma 2 does not belongs to R1. 2 comma 2 does not belongs to R1. So that is why you can say this is a non-reflexive relation. So next is irreflexive relation. A relation R and set A is said to be irreflexive relation. A comma A does not belongs to R for all A belongs to A. For example, you see that A is equals to 1 comma 2 comma 3 comma 4. Let R1 R to be the relations on A defined by R1 is equals to 1 comma 2 comma 2 comma 3 comma 1 comma 3 2 comma 4 4 comma 2. So in this relation there is no identical elements like A comma A, that elements are not belongs to R1. So that is why R1 we can say that irreflexive relation. There is no identical order pairs. That is we can call it as irreflexive relation. Now when you see that R2 1 comma 1 2 comma 3 3 comma 4 2 comma 4 4 comma 1. Here 1 comma 1 is there, but 2 comma 2 3 comma 3 4 comma 4 does not belongs to R2. So it is non-reflexive relations. Non-reflexive relations. So now the total number of irreflexive relations that can be defined as set A on set A with number of elements in A is n, that is 2 power n square minus n. So for non-reflexive relations, total relations minus irreflexive relations or reflexive relations, 2 power n square minus 2 power n square minus n. This is the non-reflexive relations. Now we have a problem. Let n of A is equals to m, n of B is equals to n. Then the total number of non-empty relations, we have taken including these empty relations. So non-empty relations is 2 power mn minus 1. Total number of relations is 2 power mn. So non-empty relation is except pi set. Non-empty set, we get 2 power mn minus 1. Let A is equals to 1, 2, 3. Then the total number of distinct relations that can be defined over A is A has 3 elements. So the cardinality of A is 3. A is relation to A only. R is relation A to A. R relation from A to A. So number of subsets is 2 power 9. So number of relations is equals to 2 power 9 distinct elements, distinct order pairs or distinct relations will get. Total number of distinct relations that can be defined as 2 power 9. Remaining next class we'll discuss symmetric relation, transitive relation, equivalence relation with their problems